Hey, hi and welcome back. So in this video, I am going to show you the demonstration of power supply section. Along with that, we will see some testing and troubleshooting technique for the power supply section. Alright, so now let's start with this video. So now let me tell you what you're going to learn in this video. So the first point is testing and troubleshooting. So as I already told you, we are going to discuss the testing and troubleshooting technique associated with the power supply section. So we are going to discuss every single thing in detail related to testing and troubleshooting, and also I will discuss how to resolve the issues related to power supply section. Okay. Then the next point is practical demonstration. So again, in this case, we are going to provide 12 volt input on the input side of 7805 IC. And we are going to check whether we are getting 5 volt on the output side or not. Okay. So that's going to be the practical demonstration of 7805 or power supply section. And in the end, I'm going to discuss the mistakes that you should avoid while dealing with the power supply section. Okay. So that's how basically we are going to cover this video. Now let's start with this video. So now let's start with the testing and troubleshooting of the power supply section. Okay. So always remember, whenever you receive the assembled PCB means when all the components are actually assembled on the PCB. Okay. So it is also called as PCBA, which stands for PCB assembled. Okay. So when you receive the assembled PCB, always remember you should never provide the power directly to the PCB. Okay. So first of all, what you have to do, once you receive the assembled PCB, you have to check the PCB, visually. Okay. So you have to check whether all the components are properly soldered on the, on the PCB or not. Whether there is any kind of, short circuit or floating solder ball is present on the PCB or not. Okay. So once the visual inspection is done, then you have to check the, the section of your interest. Now, in our case, the section of our interest is power supply section. So first of all, what you have to do when you are testing the power supply section, you have to check the input and output side. And you have to check whether there is a short circuit on the input side of power supply or whether there is a short circuit on the output side of the power supply or not. Okay. Now, let's consider that if there is a short circuit on the power supply and if you directly provided the power, from the external power source, then the maximum amount of current is actually going to flow through that shorted path. Okay. And because of that, your PCB may get damaged. That's the reason, first of all, you have to check whether there is a short circuit present on the input and output side of power supply or not. Okay. And same thing we are going to do now. Let's check whether there is a short circuit on the input side and output side of power supply or not. Okay. So for that, I'm going to bring the multimeter in the frame. Alright, so we have the multimeter in our frame now, and let me put this multimeter in the continuity mode. So we have the multimeter in the continuity mode, so you can hear the sound. So whenever we will find the short circuit, it's going to give us beep sound like this. Okay. So first of all, now let's check whether there is a short circuit on the input side of the power supply or not. So I'm going to consider the reference point. So this is basically the ground point we have already discussed. The tab is actually connected to the ground of the PCB. Okay. So this is basically the reference point, and we are going to check the short circuit on the input side of power supply. And we know that this particular path is actually going towards the input pin of the IC. So if we check the short circuit between this point, which is input pin of IC, and the ground path, so you can see there is no beep sound. It means that there is no short circuit on the input side. Okay. So this is actually a really good indication. Now we have actually checked the short circuit on the, on the output side of diode. You also have to check the short circuit on the directly on the 12 volt input side. So for that, I'm going to connect, just a second, it's not visible from this side. So I'm going to connect this positive point to this side. And after that, I'm going to connect the another point at this point. Okay. So you can see still we are not getting the short. It means that everything is okay on the input side of this power supply section. Okay. So we saw that everything is okay on the input side. Now let's do the same thing on the output side of power supply. So again, I'm going to connect the ground at this point, and later I will connect the positive terminal of the multimeter on the output side. So again, you can see we are actually not getting the short between the ground and the output side. It means that again, there is no problem on the output side of power supply, and we are actually good to go ahead. Okay. So now I will move this multimeter from the frame, and let me bring this PCB in the center. Alright, so we got to know that there is no short circuit on the input side, and also there is no short circuit on the output side. So this is actually a good indication that we can actually power our system with the external power supply. Okay. But let's consider that if there is a short circuit on the input side, then what could be the reason for that particular short circuit? Okay. So this is actually very important point to discuss. So that short circuit can be because of this capacitor that we have connected, C1 capacitor, MLCC capacitor, or the short circuit can be also because of this capacitor, which is electrolytic capacitor. So capacitor could be the reason for the short circuit. Generally, sometimes the capacitors will be shorted. Okay. So in that case, what you have to do, you have to actually remove the capacitor from the PCB, and then you have to check the short circuit, by using the continuity mode. You have to check, you have to connect the two terminals of multimeter to the two terminals of capacitor, and you have to check whether that particular capacitor is shorted or not. Okay. So this is basically the method, to check whether the capacitor is shorted or not. Because if you have the capacitor on the PCB, it means that all the capacitors which are actually present on that particular line, they will be shorted, right? So the only solution to check with which capacitor is actually shorted is to remove that particular capacitor, or you have to remove one capacitor one by one, and later you have to externally check whether that particular capacitor is shorted or not. Okay. So I hope that this particular point is now clear, that the one reason for the short could be the capacitor, and the solution is you have to remove the capacitor from the power PCB, and you have to externally check whether the capacitor is shorted or not, and if it is shorted, then you can replace that particular capacitor. Okay. Then the second reason for the short circuit could be the problem in the PCB. Okay. So in that case, you have to visually check, you have to do the visual inspection whether whether you are able to find out the short circuit on the PCB or not, or you can also check in the layout. Okay. So that's basically the second reason. Then the third reason for the short circuit could be because of IC. So if the IC is damaged, then maybe the IC may short the input side. Okay. So that could be the actually third reason for the short circuit on the input side. So you have to check these 3 points if you find the short circuit on the input side. And again, on the output side, you have to do the same thing. You have to check the output capacitor, both the capacitors, electrolytic capacitor and this MLCC capacitor. So, all the capacitors which are actually present on the plus 5 volt power line, you have to check all the capacitors one by one. If there is a short circuit on the output power line, then you will have to check all the capacitors connected on that particular power line one by one. Okay. So that's basically the only solution to find out the short circuit on the output side. So for example, if there is a short circuit on the output side, you can remove this particular MLCC capacitor. Again, you can check whether the capacitor is shorted or not. If it is not shorted, then you can again solder that capacitor on the PCB. Then if this particular capacitor is shorted, then again you have to remove it, and you have to check whether the capacitor is shorted or not, or you can also check on the PCB after removing this particular capacitor whether you are getting the short on the PCB or not. Okay. So likewise, you will have to do for the all the capacitors which are present on the plus 5 volt power line. Okay. So one by one you have to remove the capacitor, and you can check the capacitor externally whether it's shorted or not, or you can check the power line. Okay. So I hope that this particular point is clear now. So in our case, we found that there is no short circuit on both input and output side. So we are good to go ahead, and now let's power our system, and let's check whether we are getting the expected output voltage on the output side of 7805 IC or not. Okay. Alright, so now let me set the multimeter's knob to 20 volt or in voltage mode, and now let's power our circuitry, okay, or our system. So I have switched on the power supply now, and let me power our system. So you can see, alright, so this actually DC female jack is little loose. That's the reason it's disconnecting again and again. So let me power it properly. Alright. So the power is now provided and let's check the voltage on the input side first. So I'm going to connect this terminal to the ground. This is actually the positive side. Let me change the polarity of multimeter. The terminals. So this is basically the positive side and this is the negative side. So you can see on the multimeter we are actually getting 12.12 volt. Okay. So we have provided 12.12 volt on the input side of this 7805 IC. So again, let's check the voltage on the input side of 7805 IC. So you can see we are actually getting 11.8 volt. It's because rest of the voltage is actually dropping across this Schottky diode. Okay, that's the reason we are getting 11.8 volt on the input side of 7805 IC. Okay, now let's check the output side. So let's check at this point because this is the output capacitor. So on the output side, you can see we are getting a stable 5.03 volt. Okay. So this IC is behaving as expected and we are getting the voltage as expected as per the data sheet, which you can see on the multimeter 5.03 volt. So again, at any point, if you check the voltage, you are going to get the same voltage, 5.03 volt. Okay. So I hope that the testing and troubleshooting of the power supply is now clear to you. We are just left with the voltage drop across the diode. So let's check the voltage drop across the diode. So I will connect one terminal here and I will connect another terminal here. So you can see on the multimeter, we are actually getting a 0.29 volt drop on the Schottky diode. Okay. So that's basically the drop across the diode. Right now the system is actually draining less current. That's the reason the drop across the diode is low. You know, when the system will start draining more current, the drop across the diode it's actually going to increase and you will get the same value that you saw in the datasheet for SS14 diode. Okay, it's going to be 0.35 volt, somewhere around that. Okay, the voltage drop is actually voltage drop across the diode is actually the function of the current which is flowing through the diode. So at this moment the voltage drop across the diode is 0.29 volt, okay, or 0.28 volt. So that was all about the power supply section, testing and troubleshooting of power supply section. I also showed you the practical demonstration of power supply section. Now we are just left with the mistakes. So let me share the mistakes that you should avoid while dealing with the power supply section. So the first mistake that you should avoid, and I have already discussed that particular mistake, it is you should never power your system before checking the short circuit on the input and output side of power supply. Okay, so you should always check whether there is a short circuit on the input side or whether there is short circuit on the output side of power supply section. Okay, if you provide without checking the short circuit, let's say that you missed the short circuit test and you directly powered your system from an external lab bench power supply, then in that case what will happen, the maximum current is actually going to pass through that particular shorted path. And if that particular track is, if it is not capable to pass that particular current or that much amount of current, then that particular path may get damaged. Okay, so that will actually damage your PCB. So you always have to make sure that you have to check the shorts on the input side of the power supply and also on the output side of power supply. Okay. And one more thing that you have to remember here is whenever you are powering your system for the first time, for example, if you are powering your system with the help of lab bench power supply, then you get the flexibility, to limit the amount of current which is flowing from the lab bench power supply. So in lab bench power supply, there will be provision like how much current you can pass on the output side of that particular channel of power supply. Okay. So you should limit the output current of the power supply when you are powering your system for the first time. You can limit the output current as per your requirement or as per your application's requirement. Now in our case, we can limit the output current to 100 milliampere or somewhere around that. Okay, some other application might have the output current higher output current requirement. So you will have to limit, set the output current of a lab bench power supply to even more higher limit. So whenever you test your system for the first time or whenever you are powering your system for the first time, you always have to limit the current of lab bench power supply. And once you are sure that there is no short circuit on the input side and output side or on the entire PCB, then you can actually increase the current of lab bench power supply or external power source. Okay, so that was the point that I wanted to discuss. And another mistake that you should avoid is you should always keep your hardware on the non-conducting surface. Okay, so at this moment I have kept this hardware on the wooden platform. So you should never keep your hardware on the conducting platform. For example, if you keep your hardware on a conducting platform, then maybe because of short circuit your PCB may get damaged. Okay, so that's the reason, in order to avoid such kind of situation, you always have to make sure that you have to keep your system or the hardware that you are testing on the non-conducting surface. Generally, ESD mat is actually the standard. Whenever we test our hardware, we have to we actually place the hardware on the ESD mat. ESD stands for electrostatic discharge. Okay, so in order to protect our system from the ESD, we generally place the hardware on the ESD mat. Okay, but in our case, I'm not concerned about the ESD in our hardware. So even if I check the hardware on the wooden surface, it's completely fine. After that, one more thing that I want to tell you here is you should always use standoffs. Okay, so this is basically the third point in mistakes. You should always use the standoffs for the hardware or whichever hardware you are testing. So this is basically going to give clearance like this. So it's going to give some clearance from the surface to the hardware. Okay, and this is actually going to protect your hardware from any kind of unwanted short circuit, because when we place the hardware on the surface, if there is a wire strand on the bottom side, then because of that the short circuit may happen and it may damage your PCB. So having a standoff on the PCB is basically a right approach while doing the testing of your hardware. Okay, so I hope that every single thing that we discussed related to the power supply section and generalized information related to the hardware is clear to you. And if you still have any kind of doubt related to any point on our hardware, then definitely you can ask me and I will help you with that. Okay, alright, so that's what I wanted to tell in this video. Now I will see you in the next video, which is about testing microcontroller section.